Hey class, welcome back. Hope you guys had a great break. Today we are going to start learning about quadrilaterals. Quadrilaterals are four-sided figures. Think of quad. Unlike quadratic is the second power, but quad, like a four-wheeler, they call quads. This is a four-sided figure. Now, there are special types of quadrilaterals that you need to know things about. The first one is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. And you can see that in the figure here. Remember, the arrows represent that these two lines are parallel with each other, and the double arrow means that these two lines are parallel with each other. Now, a rhombus is a special parallelogram with four congruent sides. Now, a rectangle is also a parallelogram. So it has opposite sides that are parallel, but this also has four right angles. And a square is also a parallelogram. With four congruent sides and four right angles. So you can say that all squares are rectangles, but not all rectangles are squares. You could also say all squares are a rhombus, but not all rhombuses are squares. All right, another special type of quadrilateral is a kite. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. Sorry, let me zoom out a little bit for you. And obviously you can pause and replay any of this, or you can look in the book at page 288 and you can find the same information. Now, a trapezoid is also a special type of quadrilateral. With exactly one pair of parallel sides. And to go a little bit further with trapezoids, there's something called an isosceles trapezoid. Which has a trapezoid with congruent non-parallel sides. As you can see in this figure, this side are obviously not parallel to each other, but they are congruent. Alright, so based on that information, we should be able to identify, just by the appearance of DEFG in that figure, and try to classify that quadrilateral. Obviously, DEFG is a quadrilateral. Because it has the four sides. This could also be a parallelogram, just based on the appearance that this side looks parallel to this, then this one looks parallel to this. We could also say that this could be a rectangle, because it sure looks like these sides, or opposite sides, are congruent, and they form 90-degree angles. So the most precise name for DEFG is going to be rectangle in that case. Alright, so let's put all of this together in some sort of like little flow chart. So at the top here, let's draw this diagram. Try to draw a quadrilateral without any parallel sides or congruencies. And label it quadrilateral. Now off of that, we learned about a kite, that the adjacent sides are congruent to each other. So this is going to be a kite. And they have no parallel sides. Now what happens if we have one pair of parallel sides? Well, you get something called a trapezoid. And specifically, we could have an isosceles trapezoid, as long as these sides are parallel and these things are congruent. This is where we have the isosceles trapezoid. Now what happens if we have two pairs of parallel sides? We get something called a parallelogram. And as we know, parallelograms can be split up into two different types. If it has four 90-degree angles, we call this one a rectangle. And if it just has four congruent sides, we call this a rhombus. And a special type of rectangle and a special type of rhombus form what we call something has four sides congruent and four right angles. Sorry, it's not perfect, but this is what we call a square. All right, moving on. We're going to use properties of these special quadrilaterals to be able to find values of x's, to find lengths of sides. So since we're dealing with a kite, we know that the adjacent sides are congruent to each other and opposite sides are not congruent. So the top two are congruent, the bottom two are congruent to each other. So we can set 2x plus 4 equal to 3x minus 5. And we can set 2y plus 5 equal to x plus 6. Now, since this one has x's and y's in it, let's go over here first and let's solve this for x. So let's subtract off 2x. We're going to add 5. So x equals to 9. Since x is equal to 9, let's go ahead and plug it in. So we have 2y plus 5 is equal to 9 plus 6. And now we'll be able to solve for y. So I'm going to subtract off 5. So 2y equals, that 15 minus 5 is 10. Divide by 2, y equals 5. So it does ask you to find the lengths of all sides. We plug in 5 here. We get 2 times 5, which is 10, plus 5 is 15. Plug in 9 here. Well, that's going to be 15. And if we plug in 9 here, 2 times 9 is 18, plus 4 is 22. And then this side better be 22. 9 times 3 is 27, minus 5 is 22. And now the next one is a special quadrilateral, mainly a special parallelogram called a rhombus. And this one's asking us to find the values of the variables and then the lengths of all sides again. So a rhombus has all sides that are equal to each other. So all you have to do is take 2 of them, 2x minus 3, and set it equal to 3x minus 10. You subtract 2x, you get negative 3 equals x minus 10. If we add 10 to both sides, you get x equal to 7. So if x is equal to 7, we should be able to plug that into all of these places. 18 minus 7 is 11. 2 times 7 minus 3, that's also 11. 3 times 7 minus 10 is 11. And obviously 7 plus 4 is 11. All right, I hope this helped. And again, this will be posted on the website. You should be able to go look at this later on if you'd like, or just have the teacher rewind and you can replay. Best of luck to you with this, and I'll be back at the beginning of second semester, but we'll be doing a couple more videos for you so that you guys can learn the next couple units or lessons before the final exam review starts. Again, best of luck, and I'll see you guys soon. Bye.